Starting that off with a little nose scratch. It's great. Okay, now that we know how to do integration, we're going to do it with a U-substitution and a defined integral. Okay, so now we have our bounds from 0 to 2. We're actually trying to solve this for a number, not just the antiderivative. There are two ways to do this. It is up to you which way you do it, which way you feel most comfortable with, but you will have to be able to recognize both. Okay? So this first one is just our U-substitution, plain and simple, and then we're going to use our bound 0 to 2 to solve. So let's dive in and see what this is going to look like. I'm going to start with my U-substitution. So I'm going to say U equals 4 minus x squared. So my du is going to equal negative 2x dx. So I'm going to have to go in and I'm going to balance with a negative 2. I'm going to multiply by a negative 2, so I'm going to balance with a negative 1/2. So I'm going to have negative 1/2 the integral of the square root of u du. Notice how I don't have my bounds here. The reason I don't is because 0 and 2 are in terms of x. And right now I'm in terms of u, so I'm going to drop the 0 and 2 for a second. So I'm going to antiderive this. The antiderivative I'm going to get, I have my negative 1/2 out front. This is going to give me u to the 3/2 times 2/3. Okay, so here, this ends up looking like negative 1/3 u to the 3/2. We'll go ahead and make our substitution, actually. Let's put u back in there. So this is going to be 4 minus x squared to the 3/2. So essentially what we're looking at here, this is equal, evaluated from 0 to 2, is going to be equal to our integral 0 to 2 x times the square root of 4 minus x squared dx. Now that I'm back in terms of x and I'm ready to evaluate, this is going to equal my integral, so my 0 and 2 are back. So I'm going to plug in 2. Well, that's interesting. 2 squared is 4, 4 minus 4 is 0, so this all gives me 0, minus, now I'm going to plug in 0. 0 squared is 0, 4 minus 0 is 4, square root of 4 is 2, 2 cubed is 8, so that's going to give me negative 8/3. So 0 take away negative 8/3 is going to be positive 8/3. And there's my answer. So the U substitution works. Again, with our equal signs, we just want to be careful because as soon as we're in terms of U, we're no longer using 0 and 2 because those are in terms of x. Once we're back into terms of x, we're going to bring back our 0 and 2 and evaluate to get our solution. So what's going to change here with the second method is everything to do with our bounds. Here, 2 and 0 are in terms of x. So we had to get back into terms of x to use 0 and 2. Well, what happens if I stay in terms of u? Watch what happens. So, again, u substitution, 4 minus x squared, du is negative 2x dx. So I'm going to multiply by negative 2, balance here. So I'm going to have negative 1/2 the integral, the square root of u du. And what I'm going to do here is I'm going to change my bounds so they're in terms of u. So that's what I'm doing here. I'm going to change bounds or limits into terms of u. For example, if I take 2 and I plug it into u, 4 minus 2 squared is 0. So 2 is now 0 in terms of u. If I plug in 0, 4 minus 0 squared is 4. So now my bounds are in terms of u. I don't have to go back here at all. X has now done its part, it's gone. This is my new integral, and I'm going to move forward from there. We can see these numbers, 0 and 4, pop up here. Look, I plugged 2 in. 2 squared is 4. 4 minus 4 is 0. I used that. Then I plugged in 0. 0 squared is 0. 4 minus 0 is 4. I used my 4. So I'm just doing that now so I don't have to go back to terms of x. And now I'm ready to solve. So I'm going to take the antiderivative of the square root of u. So I've got my -1/2. That's going to give me u to the 3/2 times that 2/3 evaluated from 4 to 0. So I plug in 0. That's going to give me 0. And now I'm going to plug in 4. The square root of 4 is 2. 2 cubed is 8. And that gives me my -8/3. That was kind of messy, a little sloppy, but hopefully we still understood. And I'm still getting 8/3 as my solution. Even if I step away and I'm looking at the amount of work here, the amount of work from the blue and the amount of work of the red is different. Red is shorter and quicker because I changed my bounds into terms of u. So I never had to go back to x. I was able to just use this function to solve. Okay, if you got questions, let me know. Send me an email. Let's make sure you understand what we're doing.